Throughout the history of science, humanity has grappled with the profound question of how the universe originated. This quest has led to the formulation of various theories, among which the most recognized is the Big Bang theory. This theory has garnered substantial support through extensive research and the dedicated efforts of thousands of scientists, who have provided a wealth of evidence regarding the universe's beginnings. Yet, in our contemporary scientific landscape, the emergence of advanced technologies has opened the door to novel ideas and perspectives that challenge long-held beliefs. One prominent voice in this ongoing discourse is astrophysicist Neil deGrasse Tyson, who has significantly contributed to the evolution of our understanding of the cosmos. A particularly exciting development in this field is the James Webb Space Telescope, JWST, which has recently unveiled remarkable findings that may prompt a re-evaluation of the traditional Big Bang theory. With the discovery of approximately 750 new galaxies, many of which differ significantly from prior expectations, scientists are being urged to reconsider what they thought they knew about the formation and evolution of galaxies. The JWST was specifically designed to enhance our understanding of these cosmic phenomena, so it is unsurprising that its findings are reshaping our interpretations of the universe. Historically, researchers have maintained that the Big Bang theory offers the best explanation for the origin of the universe. According to this theory, roughly 13.7 billion years ago, the universe emerged from a mysterious astronomical event akin to a dramatic cosmic birth. This event is often depicted as a singular explosion that marked the beginning of space and time, leading to the expansion and cooling of the universe. However, the images captured by the James Webb Space Telescope challenge this established narrative. They reveal galaxies that are not only smaller and smoother but also older and more diverse than what the Big Bang theory predicts. For instance, the theory posits that as the universe expands, galaxies should appear larger the farther away they are, yet, the newly discovered galaxies defy this expectation, raising critical questions about our understanding of cosmic evolution. The Big Bang theory also proposes that at the inception of the universe, all matter was concentrated into an extremely dense point known as a singularity. This singularity was believed to be incredibly hot, far hotter than any conditions we can replicate or measure today. The concept of the singularity stems from Albert Einstein's theory of general relativity, which describes how all matter in the universe was compacted into an infinitesimal space with immense density. This scenario suggests a vast amount of mass and energy was concentrated in a tiny volume, leading to the universe's dramatic expansion. In simpler terms, scientists have historically asserted that the theory of the universe's origin explains how the cosmos began. However, the new data from the James Webb Space Telescope prompt a reassessment of this idea. The characteristics of the galaxies it has identified do not align with the predictions of the Big Bang theory, suggesting that our understanding of the early universe may not be as definitive as previously believed. Currently, it is widely accepted that all the energy in the universe originated from this hot, dense singularity. Following this initial state, the universe began to expand and evolve over billions of years, gradually taking the form we observe today. This expansion is thought to have been initiated by an event referred to as cosmic inflation, during which the universe expanded at an astonishing rate, even exceeding the speed of light. It was as if the very fabric of space itself was stretching, carrying everything within it along for the ride. As researchers continue to analyze the data collected by the James Webb Space Telescope, they are faced with a striking revelation: the newly identified galaxies do not exhibit the chaotic and disturbed characteristics expected from the Big Bang. Instead, they appear to be smooth disks and orderly spiral shapes, resembling the galaxies we observe in the present universe. This surprising finding challenges the notion that collisions and disturbances are a typical part of galaxy formation. Moreover, the JWST's findings suggest that there are far more galaxies than the Big Bang theory initially predicted. Historically, the theory made certain predictions about the number and distribution of galaxies throughout the universe. Yet the telescope's images reveal a much larger abundance of galaxies than expected, prompting researchers to question the accuracy of the theory's predictions. Some scientists have expressed concern, as these discoveries do not align with their long-standing assumptions about how galaxies form and evolve. In addition to the unexpected abundance of galaxies, the smoothness observed in many of these newly discovered galaxies conflicts with the predictions of the Big Bang theory. According to the theory, galaxies should exhibit irregularities and variations in their structures due to the processes of formation and evolution. However, the images captured by the James Webb Space Telescope show galaxies that are unusually smooth, lacking the expected complexity and roughness. This raises significant questions about the mechanisms behind galaxy formation. The prevailing narrative of the Big Bang posits that in the universe's early moments, a process called nucleosynthesis occurred. This process involved the formation of light elements such as hydrogen and helium, which laid the foundation for the development of stars and galaxies. As cosmic history unfolded, these primordial building blocks played a crucial role in the evolution of matter, transitioning from a primordial sea of particles and energy to a state where matter began to coalesce into the structures we observe today. The Big Bang Theory had anticipated a universe filled with galaxies that were chaotic and disturbed due to various collisions and interactions. However, the images provided by the James Webb Space Telescope depict a different story. Rather than showcasing turbulent and disordered galaxies, the photographs reveal smooth, well-structured disks and orderly spirals. This raises further questions about the role of collisions in galaxy formation. If these galaxies exhibit few or no signs of collisions, as suggested by the data, it becomes increasingly unlikely that smaller galaxies could evolve into the larger structures we see today. Another critical aspect of the Big Bang Theory is its assertion that as the universe expands, objects should appear smaller with increasing distance due to the effects of redshift. Yet astronomers have observed a striking pattern in which galaxies tend to cluster together in large groups, forming complex networks throughout the universe. This large-scale structure aligns with the predictions made by the Big Bang Theory regarding how gravity influences the distribution of matter. The gravitational effects anticipated by the theory are consistent with our observations today. Gravity pulls matter together, leading to the clustering of galaxies and the formation of interconnected filamentary structures known as the cosmic web. The presence of these galaxy clusters and the cosmic web structure strongly supports the Big Bang Theory, as they align with the gravitational effects expected from the initial dense and expanding state proposed by the hypothesis. Returning to the size and characteristics of the galaxies identified by the James Webb Space Telescope, we see that these findings contradict earlier beliefs about the origins of the universe. According to the Big Bang Theory, small galaxies should evolve and grow through collisions and mergers with other galaxies. However, the JWST's observations cast doubt on this idea. If galaxies were indeed colliding and merging as expected, we would see evidence of these interactions in the form of distortions or imprints in the surrounding galaxies. Instead, the images reveal a surprising lack of evidence for such collisions, leading researchers to question the validity of the traditional narrative surrounding galaxy formation. While the Big Bang Theory remains a well-supported hypothesis, recent discoveries have sparked debate regarding its validity. Among the compelling evidence for the theory are observations of the redshift of light from distant galaxies, which support the idea of an expanding universe. These observations indicate that galaxies are moving away from each other in all directions, consistent with the predictions of the Big Bang Theory. Additionally, the abundance of light elements, such as hydrogen and helium, found throughout the universe aligns with the predictions made by the Big Bang Theory. The large-scale distribution of galaxies revealed through astronomical surveys also matches the patterns predicted by the theory. One of the most significant pieces of evidence for the Big Bang Theory is the discovery of the cosmic microwave background radiation, CMB. This faint radiation fills the entire universe and represents the afterglow of the Big Bang. First detected in 1965, the CMB closely aligns with the predictions made by the Big Bang Theory. The observed characteristics of the CMB, including its uniformity and temperature distribution, strongly support the idea that the universe was once in an incredibly hot and dense state before undergoing expansion. Despite these compelling pieces of evidence, recent findings have introduced challenges to several aspects of the Big Bang Theory. The presence of galaxies with ages that seem to predate the Big Bang contradicts the theory's central premise, suggesting that the Big Bang may not have occurred as initially thought and that not everything in the universe originated from this event. Proponents of the Big Bang Theory had anticipated that as the James Webb Space Telescope looked further into space and back in time, the number of recognizable galaxies would decline, eventually leading to a so-called dark age of the universe. However, recent research shows that even a couple of 100 million years after the hypothetical Big Bang, galaxies as massive as our Milky Way were already in existence. The JWST's images reveal a greater abundance of massive galaxies at redshifts greater than 10 than scholars had anticipated, challenging the validity of the Big Bang Theory. Moreover, the Big Bang Theory is associated with a number of incorrect predictions, with only a single accurate prediction regarding the abundance of deuterium, a type of hydrogen. Some of these incorrect predictions include estimates of helium abundance, which are off by a factor of 2, and predictions for lithium abundance that are off by a factor of 20. Additionally, the theory fails to explain various anomalies, such as the absence of the expected illusion where objects should appear smaller with increasing distance. In light of these discrepancies, scientists are increasingly questioning the validity of the Big Bang Theory. By focusing on the colors of distant galaxies in the infrared spectrum, astronomers can estimate the ages of the stars within these galaxies. Some of these galaxies appear to contain stellar populations that are over 1 billion years old. The notion that the universe can be less than 13.8 billion years old raises critical questions about the established timeline of cosmic history. As we look to the future, researchers remain dedicated to refining our understanding of the cosmos. The James Webb Space Telescope is poised to play a pivotal role in this endeavor, offering unprecedented insights into the universe's formation and evolution. With its advanced technology and capabilities, the telescope will continue to unveil new galaxies and cosmic phenomena, prompting scientists to re-evaluate and revise their theories. In conclusion, while the Big Bang Theory has long served as a cornerstone of modern cosmology, the latest discoveries from the James Webb Space Telescope highlight the complexities and mysteries that remain within our understanding of the universe's origins. The newfound galaxies challenge established beliefs, suggesting that the formation and evolution of galaxies may be more intricate than previously imagined. As science continues to advance and new data emerges, our understanding of the cosmos will undoubtedly evolve, prompting us to ask even deeper questions about the nature of existence itself. The exploration of our universe is far from over, and the pursuit of knowledge will continue to drive humanity's quest for understanding.